All right, section 3.1 is on solving systems of equations by graphing. So did anybody actually start their homework already?
Yes.
So that was pretty easy?
Sorry, that was the
So it's not too bad. So if we have a system of equations is a set of two or more equations containing two or more variables. So like two lines or a parabola in a line or something like that. Now a linear system is a system of equations containing only linear equations. So linear means line, so only lines. Now a linear system, you could have two lines that intersect, you could have two lines that are parallel, you could have all kinds of different things. All right, so number one, it says use substitution to determine if 1, -2 is an element of the solution set of the linear equation. So just of the equation. So we're just going to plug it in and see if it is true or if it's false. So I'm going to plug in x is 1, y is -2. So I'm going to have -2, and I'm seeing if it's equal to 2 times 1 plus 1. -2, is that equal to 3? No. So this is no. It's not an element of the solution set. So I'll say no, not an element of solution set.
You really capital E for element.
It's actually element is like a little element like that. Is that what you're talking about?
Yeah.
Okay. So basically there's a lot of points that are on this line. Every point on that line would be an element of the solution set. This one doesn't work. All right, B, so plug in 1, -2. So 1 for x, -2 for y. -2 does equal -2. So yes, this is an element of the solution set. Okay, those are just for one equation. Yes?
Do we actually have to write out?
No, you don't have to. So number 2, it says use substitution to determine if -2 is an element of the solution set for the system of equations. So this time it's a system. So that means it needs to be a solution for both equations. So you're going to plug into both. So the first one I have is x plus y equals 0. The second one is 7y minus 14x equals 42. I'm plugging in -2 for x, 2 for y. So I have -2 plus 2. That does equal 0. Now be careful in this one, the y's first, so it's 7 times 2 minus 14 times -2. I'm seeing if that's equal to 42. This is 14 plus 28. Does that equal 42?
Yes.
Yeah. So yes, this is the solution of the system. Okay, think about what that means. These are two lines, and we said that this is a point on both of those lines. So there's two situations that could happen. We have one line, another line, and it's that point that was common to both of them, so it's the intersection point. But we could also have two lines that are exactly the same line. Do you guys see that? So you could also have one line and then the other line coincides with it. It's exactly the same line. Well then, yeah, it could be a solution, a point in the solution set in that case. Does that make sense? Okay.
But that wouldn't be the case if they weren't linear, right? Like if one of them was like...
Yeah, if they were like functions, like polynomial functions, so you're saying like that, you could have like a no solution, or you could have more than one solution or something like that. All right, so number 3, it says use a graph to solve the system. So we're going to graph both of these equations. So the second one's really easy to get in the y equals form. It's just y equals x minus 2. But 2x minus 3y equals 3 is a little bit harder. So I'm going to subtract the 2x over. Oh, give myself some room. So I'm going to have -3y equals -2x plus 3. And I'm going to divide everywhere by -3. So I get y equals, think about it, if I'm dividing by -3, I'm going to have positive 2/3 x minus 1. Yes, you could keep it. Are you saying could you use intercept method? Yes. Why did I not want to use intercept method on this one though?
Because you get 1.5.
Yeah, 1.5 is not very nice. I mean, you could, but it'd be really tiny and it'd be kind of hard to draw. So, did it work? All right, you might want to have a straight edge for this homework assignment too. I meant to bring my rulers in here. I forgot. Yeah. So draw the two lines. So the first one I'm going to draw in blue so you can see it. So I'm going to do -1 as my y-intercept. My slope is +2/3, so I'm going to go up 2, right, 1, 2, 3. It's right there. Now on these ones, it's kind of nice to do a couple points. Like I would go up 2 and write 3 again. So go up 1, 2, write 1, 2, 3 again. Or you could start at your original and go down 2, left 1, 2, 3 again. And you can do that a couple times. Draw a nice straight line. Now the second equation I'm going to draw in red. So y equals x minus 2. So I'm going to go down to -2. And then my slope is +x. So I'm going to go up 1, right 1, up 1, right 1, up 1, right 1. See how it's nice when you do a couple points? Because then you can really tell that it's crossing at that point I just drew. So at this point right here. Now on your homework, you need to draw the point that they're intersecting at. That's what it means by solving the system, finding the intersection point. So that intersection point is 3, 1. Okay, that's your answer. Yeah.
If we could solve it without graphing.
Nope, you gotta graph. So in this section, you have to graph. Later on, we're gonna learn some other methods. All right, number 4, so use the graph to solve the system. So the first one, I'm gonna have y equals 3x minus 2. And the second equation is going to be y equals -x minus 6. Okay, so the first equation is y equals 3x minus 2. So I'm going to start at -2. I'm going to go up 1, 2, 3, right 1. Up 1, 2, 3, right 1. So do it a couple times. You could also do it in the other direction. So down 1, 2, 3, left 1. Oops. Use a straight edge. Mine's a little wobbly. And the other one starts at -6 for the y-intercept. Notice it's the y-intercept, right? Some of you guys were doing x-intercept still on your test. So down 1, 2, 3, 4, 5, 6. And your slope is -1. So you're going to go down 1, right 1, down 1, right 1. So that way it's sloping downwards in the end. You could also go up 1, left 1, and then you'll see that it crosses at that point right there. So it's 1, -5. Okay, and that's your answer. Now, if you weren't sure, let's say you got really wobbly, you didn't have a straight edge. -5, thank you. -1, -5. Thanks. All right, so if I wasn't sure, what did you do? Yeah, Mom.
You plug in both points into the equation and see if they're into both equations.
Yeah, you plug in -1, -5 into both the top equation and the bottom equation and see if it's true. I would probably even plug into the original just to make sure that you graph the lines correctly even. So, all right, so next up. So there's 4 different terms you're going to need to know. So this is the big difference from Algebra 1 because you probably didn't learn these terms in Algebra 1. Maybe. Okay, so the big thing is you want to decide if it's consistent or inconsistent. So if I said Sam West is a very inconsistent person, I don't think he is, but I don't want to be Sam's friend because he's very inconsistent. Is that a positive word or a negative word?
Negative word.
What does that mean?
You can never tell what they're gonna do.
Yeah, you can never kind of tell what he's going to do. He's
True.
flaking out on me. Yeah, so if someone's inconsistent, they're not very reliable, right? So an inconsistent system is something that's going to give you no solution. So you're going to try to solve it, and then you'll end up with something that looks like 8 equals 10 or something weird like that. It doesn't make any sense. All right, so that's inconsistent. So no solution. All right, consistent system is one that comes up with a solution. So it has either one solution or an infinite number of solutions. So once you decide if something's consistent or inconsistent, then if it's consistent, you decide if it's dependent or independent. Okay, so we'll try some examples. So go ahead and graph numbers 1, 2, and 3 in your notes. So go ahead and try those graphs, and then we'll talk about them. Okay, so as I was walking around, it looked like you guys were doing pretty well. So the first one, if you use the intercept method, the x-intercept is plug in 0 for y, So it's like you're covering up the y, right? X equals 4. Cover up the x. You get negative y equals 4, so y equals negative 4. So that's one way you could do that with the x-intercept, y-intercept method. So it's 4, 0, 0, negative 4, and then draw the line. Okay, now the second one, it's pretty easy to solve for y. It's just y equals negative 2x plus 5. So go up to 5, 1, 2, 3, 4, 5, and go down to right 1, down to right 1, down to right 1. It's looking like they're intersecting at 3, negative 1. But if you weren't sure, you could always plug those back in. If you plug in 3 to the first one, 3 minus negative 1 is 4. 2 times 3 is 6, plus negative 1 is 5. So that's the solution. All right, the next one, so x-intercept, y-intercept method, if you did that, you would get x-intercept is 4, y-intercept is negative 2. Did you guys see how I got those numbers? So 4, negative 2, graph your line. On this one, if I solve for y, I get negative 2y equals negative x minus 7. So y equals, if I divide by negative 2 everywhere, it's 1/2 x plus 3.5, or 7 over 2. So go up to 3.5, which is kind of hard to graph, 3.5. And go up 1, right 2. So you're always between the grid marks. Up 1, right 2. Okay? And then draw your line. Now mine look like they're parallel, but you probably want to check to see if they actually are parallel. If you look at this first line that we drew, its rise is 2, its run is 4, so that means its slope is 1/2. Well, the slope on this other one was 1/2 as well. So parallel lines are never going to intersect. They're going to go off forever with that same distance between them. Yeah, so this one is no solution. So we write no solution on this. All right, so we'll talk about the consistent, inconsistent thing in just a second. So let's look at number 3. So number 3, when we solve this one, we have, if we solve the second one for y, I'm going to have negative 2y equals negative 4x minus 6. I'm going to divide by negative 2. So I get y equals 2x plus 3. What's weird about that? Exactly the same line, right? So you can draw the first line, draw the second line. You don't have to draw them in separate colors or anything. Just draw one line. Is it no solution?
It's all real numbers.
Yeah, all of those points match up in both lines. So it's infinitely many solutions. Infinitely many solutions.
So you write like all real numbers.
I would write infinitely many solutions, actually. That's the more technical term. If you write all real numbers, it's probably fine, but the technical term for this is infinitely many solutions.
You say all solutions.
Yeah, I guess that would work, but infinitely many solutions is really the best way to say it. Yeah. All right, now, let's go back and talk about if it's consistent or inconsistent. So the big thing, as I said, first thing is, does it work out? Is there a solution, or is there not a solution? So is it consistent, or is it inconsistent? Okay, so let's go back and look at these. So number 1, consistent or inconsistent? Consistent, because there is a solution. Once it's consistent, now you can go to the subcategory of dependent or independent. Okay, dependent means it depends on where you're located for the x value on what the y value is. That would be an infinite many solutions. So for instance, later on in math classes, you'll talk about, oh, well, if x was 0, then y has to be 3. Oh, if x was 1, then y is 5. If x was t, you'll do that in math class, then y is 2t plus 3. So it depends on what the t value is. That's why we call it dependent. I will make you guys do that in algebra too, so don't worry about that. All right, so it is consistent and independent. There weren't a multiple number of answers. It didn't depend on what x was. Okay, next one, consistent or inconsistent? Inconsistent, it was no solution. And the next one, infinitely many solutions, dependent. So it was consistent because there was a solution. There was actually infinitely many. So it's consistent dependent. So for your chart, if the lines are different and intersect, the equations are called consistent because there's an answer. The system is independent. Someone is really loud out there. Can you close that, please? Okay, next one. If the lines are different in parallel, the system is inconsistent because there's no solutions. And then we don't go into our subcategory. We don't say dependent or independent. We just say no solution exists. If the lines coincide, the equations are called consistent because there's an answer. And the system is dependent. Okay, now before I set you guys loose, I'm going to do a couple examples from 3.2 so you guys can start on the homework. You have this nice long, well, not long weekend, but you have this weekend, and if you guys want to get ahead, if you're in sports, you can at least start 3.2. So 3.2, solving systems of equations algebraically. Alright, so solving systems of equations algebraically. You probably remember this from Algebra 1, but it's been a while, so I'll do a couple of these examples. So substitution method. You want to solve for one of your variables. So when I look at number 2, so look at number 2. Which variable, x or y, looks like it's really easy to get by itself? X. Do you guys see that? See how you can get this x by itself pretty easily? You're just going to add the y over? Okay, let's do that. So I would have x equals y minus 4. Okay, now in the second equation, I'm going to use that information. I said x is equal to y minus 4. So instead of having x, so right here, instead of that x right there, I'm going to replace it with y minus 4. Now the nice thing about that is now your equation only has one variable, so you can solve it. So I'm going to have 3 times y minus 4 minus 2y equals negative 5. And this is back to algebra. We know how to do this. So it's going to be 3y minus 12 minus 2y equals negative 5. Continue solving just like normal. So 3y minus 2y is y. Add the 12 over. You get y equals 7. Now you're not done yet. Because remember, these are 2 lines. So if we have 2 lines and they are intersecting, they're intersecting in a point, right? So we actually need to find the point that they intersect at. So we have the y value, you need to find x. Usually the easiest thing is for substitution is you've already solved for that variable, x equals something. So plug it back into that equation. So x is equal to y minus 4. So x equals 7 minus 4, so it's 3. And then the final thing I look for is it's a point. So you need to write it as a point. X was 3, y was 7. And that would be so nice to me if you guys did that because it's so much easier to grade when I see that point. So please do that.
What if you switch them?
If you switch them, it's wrong, right?
Yep.
So you have to keep them in that order. It's not 7, 3. All right, try number 3. So if I'm trying number 3, that's okay. We'll do it tomorrow. So if I'm solving for, guys, we're not done yet. I know other classes are out in the hallway and they shouldn't be, but we're good. All right, solve for x. So I get x equals 3 over 2y plus 5. So that means in the second equation, instead of having x, I'm going to replace it with 3 over 2y plus 5. So I get 2 times 3 over 2y plus 5 minus 3y equals 8. 2's cancel, so I get 3y. 2 times 5 is 10. Minus 3y equals 8. What happens here?
No solution.
Right, no solution. This is an inconsistent system. So no solution. So just write no solution. All right, let's go on to addition method or elimination method. You're fine, you're fine. Grumble, grumble. All right, write both equations in standard form. So in other words, standard form is ax plus by equals c. Basically that intercept form we talked about before. That's really easy to find intercepts. Yeah, just make sure that they're integers. A can be positive or negative in this case.
Oh, okay.
And this one, yeah. So multiply the terms of one or both of the equations by constants chosen so that the coefficients are opposite for one of the variables. Confusing, but basically, let's say I'm on the third equation. I want to have like 4y and negative 4y. Okay, so you're going to multiply the top one through by some kind of number. Okay, line up the equations and add straight down. Solve the resulting equation if possible. Step 4, plug the number you have found into either of the original equations and solve for the remaining variable. And then, like always, you can check these numbers. So it's kind of nice. You can always check. Okay, now 3. Let's look at 3. We said in order to get my y's to cancel when I add straight down. Well, let's look at 1 first. See how if you add straight down, the y's go away? That's our goal. We want our variables to go away, so then we just have one variable left, because we can solve equations with one variable. So this one would be 2x equals 10. So x equals 5. Plug into one of the other equations. So y is equal to 2. That's the point. 5 for x, 2 for y. 5, 2. On number 3, you would have to multiply through by 2 on the top equation. You guys see that? In order for the y's to go away. How about number 2, though?
Can't you solve for x? Can't you like multiply out x?
Well, if I say to solve for the elimination method, then you need to solve with elimination. Is that what you're saying?
No, can't you like multiply it by something so that you
Oh, that
eliminate
the x's cancel? Yeah, you could do that. So Naomi, what do we want to do on number 2?
Couldn't you just do like, I mean, 3x minus 2x is x.
No, but then we still have x and y in our equation, right? That didn't do us anywhere. So we don't want to solve, we don't want to just get, add straight down and get x's and y's still. Yeah.
Mark, you multiply the top by 3 and the bottom by -5.
Yep, you could do that. Let's go even smaller, though. Yeah, Alex, what would you do?
Multiply the bottom one by 1.5.
Oh, that's too small. Okay, let's make it. You can multiply by 1.5
You
on the
can
bottom.
multiply the bottom by -3 and the top by 2.
Yeah, let's use the smallest numbers possible to multiply by. Kind of like common denominators. Like 6 is a lot smaller than 15, so I would get them to be 6's, you know? So just so it's easier on multiplication, because I didn't want to find -16 times 3. Not hard, but 48. All right, so if I'm multiplying through, I'm multiplying by 2 on the top and -3 on the bottom. So when I line them up, the x's are going to cancel. So my new equations are 6x plus 10y equals -32. And I have -6x minus 9y equals 27. So when I add straight down, my x's go away, which is what I want. I want for one of those variables to go away. And I get y equals -5. Then plug back into one of the originals, so the tiny numbers. That's better. So 2x plus 3 times -5 equals -9. That's -15, so when I add 15 to both sides, I get 6. So x equals 3. So that's the point, 3, -5. All right, you guys should be able to do all of the 3.1 to 3.2 homework now. Did someone say they were confused?
Did you do the test back?